Well, hello there, folks, and welcome back to the video. In today's chapter, we're going to be talking about Chapter 10, A Probability, folks. Lesson 2, Experimental A Probability.
Excuse me. Experimental probability is an estimate of the probability of an event. So experimental probability is an estimate of the probability of an event. It is called experimental because you perform activities. Okay, so we got to highlight this. So it's called experimental because we perform activities or experiments to find the number of times a certain event actually happens after repeating the experiment a certain number of times. So that's very, very key for this particular type of probability, experimental probability. We are conducting an experiment, and we get our data off of conducting an experiment. So experimental probability is approximately the number of times a certain event happens over the total number of trials or the times that you tried to do the event. So suppose we have a bag filled with marbles of different colors. You pull out 12 marbles without placing them, and 5 of those marbles are red. What is the experimental probability of getting another red marble the next time you pull a marble from the bag? All right, cool. So let's go ahead and do this experiment. So we are going to go back to Minecraft marbles, where they're all going to be kind of in this block formation. All right, so here's all our Minecraft marbles. And so we have a whole bunch of marbles, and we're just going to start picking them, and we're going to pick out 12. So I'm randomly picking them. There's one. Here's another one. Here we go. I'm just randomly picking these out. Okay, I'm randomly picking them out. Oh, there's a yellow one. Yellow is such a happy color. How many do I have right now? There's, okay, I got 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Okay, I gotta randomly pick out 12 out of this. Okay, randomly picking out 12. Randomly. Okay, so there we go. I randomly picked out 12. So you see how there's a whole lot of Minecraft marbles in here? There's a whole bunch, right? And so I'm doing an experiment. I'm randomly picking out 12 of them. And if you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I need 12. Okay, so I need one more randomly. Oh, a green one. Okay, cool. So there is my my random 12 I picked out from all of these marbles. So this is my experiment right here. Now what I see out of this experiment is that the number of marbles that are red there's 5 of them. Right? 1, 2, 3, 4, 5 out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what that means is that the experimental probability is approximately to the number of times a certain event happens. So the certain amount of times that we're going to pick a red is 1, 2, 3, 4, 5, and the total number of trials is the total amount that we picked out, which is 12. So if we're using this, sometimes you just use a P if you're talking about probability. So this would mean probability of picking a red. So P red is approximately the number of red marbles pulled from the bag is 5 out of the total number of marbles pulled from the bag, which would be 12. So the probability of the next marble being red would be this amount, 5 out of 12 from this. We're getting this probability. This is an estimate probability off of our experiment, and that's why it's called experimental probability. Okay, Cool. So let's go ahead and look at a few other examples of experimental probability. So a lot of times experimental probability happens in sports. So let's look at this. It says at softball practice, Manny had 6 hits out of 15 times at bat. What is the experimental probability that Manny will get a hit at his next time at bat? So here we have P for probability. The probability of him getting a hit is approximately the number of hits over the total number of times at bat. So in this problem, how many times did Manny hit the softball? Well, Manny hits the softball 6 times. Out of the total number would be 15. So the experimental probability, oh, we always have to reduce this, okay? So is there a number that goes into 6 and 15? Yeah, 3 does. 3 goes into 6 2 times, and 3 goes into 15 5 times. So that means that the probability would be 2/5, okay? Now, the next problem says, what is the experimental probability that Manny will not get a hit at his next time at bat? Well, if he's going to hit it 2 out of 5 times, or he's 2/5 of the time, that means for him not to hit it, we would do the 1 minus the number of hits over the total number of hits at bat. So we're going to go 1 minus 2/5. So remember, we're subtracting fractions, so we need to go ahead and get make this 1 a fraction. So it would be 1/1 minus 2/5, and then get a common denominator, which is going to have to be 5. So we're going to multiply the bottom and the top by 5. 5/5 minus 2/5. And then you end up with 5 minus 2, which is 3/5. So the probability of not getting a hit, or just saying probability of no hit, is approximately 3 out of 5. And that would be our answer. All right, perfect. Let's go ahead and look at the next couple of problems. So Pam is playing darts. She hits the bullseye 7 times out of 20 throws. So you know darts, just to talk about it really quick, it's like, you know, there are these rings in a circle, and the bullseye is the center, you know, right there. And these are like, I don't know, different colors for a bullseye. I mean, for a thing, there's like, this is red and white, and it kind of has these different colors. They alternate, and you get points. Maybe it's like this too. Isn't it like this? They have spokes. Yeah, that looks more like a dart thing. Okay, and then for those, you know, darts, they're kind of like this. They got this little pointy thing, and they got some feathers. Maybe the feathers are like this, going the other way. So that's kind of a dart. It's like a game. People throw it. And if you can hit this center of it when you throw from, I don't know, 10 feet back or something, that's called a bullseye. Okay, I'm kind of impressed with my picture. I'm not going to lie. Yeah, okay, so let's see. What is the experimental probability that Pam will hit the bullseye on her next throw? Okay, so we're going to say the probability of a bullseye would equal the number of hits over total number, I'm using this, that means number, of throws. So that's how we'd find this experimental approximate, this should be approximate probability. So the number of hits, she hit it 7 times out of 20, so that's going to go on top, 7, and the total number of throws would be 20. So there we go, it'd be 7/20. Now, can we reduce this at all? No, we can't. So we would say the probability of hitting a bullseye is equal, approximately, 7/20. And boom, there we go. All right, problem number 4 says, what is the experimental probability that Pam will not hit the bullseye on her next throw? Okay, not hitting it. So it's not that means we're going to do that 1 minus thing. So the probability of not hitting it we would go 1 minus the amount of times she hit it, which was 7 over 20. Okay, so we need to make this into a fraction, 1 over 1, get a common denominator between 1 and 20, which is going to be 20. Okay, there we go. So this becomes 20 over 20 minus 7 over 20 equals 20 minus 7 would be 13, and we keep the denominator. And so that is the probability of not hitting the bullseye. Boom, there you go. Okay, very, very cool. Okay, let's move on to the next one. How about you try this one, okay? I want you to try this one on your own, okay? So far this year, Trish's softball team has played 4 of their 20 games on Field A. I want you to go ahead and try to complete 5 and 6. So here's our friend the Pause Dragon reminding us to pause your device. When you finish with 5 and 6, go ahead and press play and we'll talk about your answers. All right, see you in a bit. All right, we're back. Let's see how you did on problem 5. So what do we have? So far this year, Trish's softball team has played 4 of their 20 games on Field A. What is the experimental probability that they will play their next game on Field A? Okay, so what's the probability of Field A? Okay, so that's going to equal number of games played on Field A over total number of games played. Okay, now the total number of games played on Field A, what was that? Played 4 of their 20 games on Field A. So that means she played 4 games on Field A, and there was a total of 20 games. So 4 20ths. Now we have to reduce this. Can we reduce 4 20ths? What goes into both 4 and 20? I would say 4 does. 4 goes in there 1 time, and 4 goes into 20 5 times. So that means the probability of playing on Field A would equal 1/5. All right, perfect. Okay, let's see how you did on problem 6. What is the experimental probability that they will play their next field on a field other than Field A? So this is not on Field A. So what's the probability of not Field A? And so if we know that the probability of playing on a Field A is 1/5, not playing on Field A, did I say Field A is 1/5? Okay, not playing on Field A would be 1 minus 1/5. Okay, then we're just going to solve this. We need to go ahead and make this a fraction, get a common denominator, which would be 5. So I got to multiply the top and the bottom by 5 to get that. That ends up being 5 over 5 minus 1/5. Okay, which ends up being 4/5. And that, to me, looks like it's in simplest form. So we're just going to say the probability of not Field A is equal to 4/5. So if you got that right, great job, and we will see you next time. Goodbye.